ये तुम्हारा ट्रांजिएंट पे बेस्ड क्वेश्चन है। ओके, इसमें इन्होंने क्या कहा हुआ है, एट, ये हमें खुद से समझना है कि एट टी इक्वल टू जीरो हमें किसकी वैल्यू निकालनी है, मेनली किसकी वैल्यू निकालनी है। पहले तो ये देखो, आई ऑफ टी की वैल्यू निकालनी है या फिर इंडक्टर के क्रॉस करंट की निकालनी है। हमें निकालनी है इंडक्टर के क्रॉस करंट आई एल ऑफ टी की वैल्यू निकालनी है जब टाइम कितना होगा 0.15 सेकेंड पे। ठीक है, क्लियर। अब सबसे पहले हमें क्या करना होता है, सेम कि स्टेप नंबर वन हमें देखना है कि स्टेप नंबर वन में हमारे पास टी लेस देन जीरो पे क्या है कंडीशन। ये तुम्हारा ओपन सर्किट है या शॉर्ट, बंद होएगा, स्विच ओपन होगा या फिर क्लोज होगा। at t less than 0, at t equal to 0 पे switch is getting closed, so before that the switch was opened. At t equal to 0 the switch is closed, so at t less than 0 the switch was opened. Switch was opened. So if the switch was open, then there is no need to draw this line. Then the resistor 8 ohm and 2 ohm, it means from the very long time current is flowing across the inductor. So in this condition inductor will behave as a short circuit, right? Because I told you in the steady state condition, if from the very long time current is flowing across the inductor, then inductor will behave as a short circuit, right? So we need to calculate the current across 2 ohm, that would be IL of 0 minus. So simply we can apply current division rule, right? CDR. Let us consider this one would be I1, this one would be I2. So I2 is equal to the total current multiplied by the opposite branch in which we need to calculate the resistance. Opposite branch is how much? 8 ohm divided by sum of resistor which are connected in parallel. So 8 plus 2. Total current they have given is how much? 2 into 8 divided by 10. 2 5 are 10. So it would be 8 by 5, right? 8 by 5 is the current we got it for IL of 0 minus is equal to 8 by 5 ampere. Understood this one, this part? Step number 1. Hmm? Okay. Now next move towards step number 2. In step number 2 we need to calculate current across inductor at infinity, right? So this would be the condition for t greater than 0. If t is greater than 0, then in that case at t equal to 0 switch is closed. So after time t equal to 0 the switch will remain closed, right? So the circuit would like, and again in the inductor it will behave as a short circuit, correct. Now as you can see that, remember I told you in the Norton theorem that current always follow low resistive path. Remember, what does it mean? That if current having two option, like current is moving from here, it is having two option. It can follow the plane path or it can follow the resistance path. So current will never follow the path where the resistance is there if he is having the option of plane path. So current will move towards back. So in this case, will the current flow across through the inductor? Yes or no? No. So in that case, IL of 0, IL of infinity, basically we can say that would be equal to 0, right? Now for this condition at t greater than 0, in the step number third, we need to calculate tau also, right? Tau is what? Tau is the time constant, correct? And its formula is L by R equivalent. L is how much? 0.4 Henry. R equivalent is the RTH. है ना? So for the RTH, we have to follow certain steps, that current source must be open circuit, voltage source must be short circuit, and wherever the inductor was placed, that must be open circuit, right? So remove this current source, then inductor will be open circuit and we have to see with respect to the inductor only, that is 0.4 Henry. So just imagine you are standing at here at the inductor A point, then you need to move towards B. So 2 and 8, tell me, they are connected in series or in parallel? I'll redraw the diagram. The diagram would be right. This is A point and this is B point. This is 2 ohm, 8 ohm and it's a plain wire. First of all, tell me that will, in this case, what would be the value of R equivalent according to you? Hmm? Not 10. Just imagine you are moving A. No, no, no. Just imagine you are standing at A. Okay? You need to move towards B. You will go through this path, 2 ohm. Will you go through the path where 8 ohm is present? Or will you choose the plain path? Tell me. So 8 ohm is coming in your path? No, na, 8 ohm is not coming in your path. So can we say that R equivalent is only equal to 2? That is equal to RTH, right? So RTH is 2 ohm. So would be zero point 0.4 divided by 2. And tau would be equal to how much? 0.25. Understood? Okay. Now we need to just substitute the value in the formula, that is IL of t equal to IL of infinity minus IL of infinity minus IL of 0 minus e raised to power minus t by tau, right? IL of infinity, how much we got it? That is, so that would be 0 minus 0 minus IL of 0 minus is how much we calculated? 8 by 5. It would be 8 by 5 e raised to power minus t by tau. Tau is how much? 0.25. 0.25. Correct? So minus and minus would be plus 8 by 5 e raised to power minus t divided by 0.25. Right? So can I write down 1 by 0.25? Remember I told you we'll never put divided by 0.25. We always used to take it on the numerator. 1 by 0.25. Can I write down like 25 by 100? Right? So it would be 25 4. Correct? So it would be 8 by 5 raised power minus 40. Correct? Hmm? Now in the question what they said that we have to calculate for the t is equal to 0.15 second. So we need to put the value of t over here, that is 0.15 second. So 8 by 5 into e raised to power minus 4 into 0.15. Now you can solve it further, then you will get a particular value. Understood?